Due to the constantly changing driving situations in urban traffic, vehicles consume a great deal of fuel. Red traffic lights in particular cause valuable fuel to be wasted because drivers allow their engines to idle while at a halt. Thanks to Directstart, the direct fuel injection system from Bosch is able to prevent this unnecessary wastage. How does Directstart actually work? Let's take a closer look under the hood. Di-Motronic detects when the vehicle has come to a halt and cuts off the engine accordingly. The speedometer constantly measures the crankshaft angle and transmits it to the electronic control unit. The electronic control unit identifies the stop positions of the individual cylinders using the crankshaft position. It then selects the cylinder suitable for direct start. It determines which actions the starter and direct injection system must complete for the start. Now the direct start system is ready to go. As soon as the driver wishes to move off, Di-Motronic instructs the starter and the fuel injection system. This is required to compress the air in the starting cylinder and is then immediately deactivated again. Fuel is injected directly into the combustion chamber. Ignition, the engine starts. Direct start with direct fuel injection is just as reliable but much faster and quieter than a conventional starting process, thereby offering an attractive solution for an automated start-stop system. In comparison with a conventional start process, direct start means a shortened engine start process. Our direct start with direct fuel injection offers fuel savings, ultimate convenience, minimum start noise, a shortened start process. Just like our motto, safe, clean, economical.
Bosch, invented for life.
Let's take a look at the entry level of the hybrid world. Under the main heading Micro Hybrids, we have the Smart Electronic Start-Stop System. The aim of the system is to save fuel and reduce emissions. Urban traffic is defined by frequent stop-and-go situations. Heavy traffic and red traffic lights mean that the vehicle must repeatedly come to a halt, while the engine continues to idle, wasting fuel and generating unnecessary emissions. This is precisely where the Smart Electronic Start-Stop system comes into its own. It consists of a modified starter, the Smart Starter Motor, and an electronic control unit which processes various sensor signals. A typical situation at a red light. The driver releases the accelerator pedal, activates the brake pedal. The vehicle comes to a halt, the driver takes the car out of gear. The engine control unit checks whether the engine is idling and no gear is engaged. The wheel speed sensor of the anti-block braking system shows 0. The electronic battery sensor signals adequate energy available for the next start. The engine now switches off automatically. Preparing for the next engine start, the starter pinion engages in the ring gear. This enables the engine to be started more quickly and the typical bump as the pinion meshes is avoided. As soon as the light changes to green and the driver depresses the clutch, the Smart Starter Motor gets the signal to start the engine. The engine starts up quickly and reliably. Engaging the gear and activating the accelerator enables the driver to move off without delay and with complete confidence. The Smart Electronic Start-Stop system provides an inexpensive introduction to the hybrid world. It can help save fuel and lower emissions accordingly, and always starts reliably and quickly.
Bosch, invented for life.
Welcome to the Bosch Virtual Driving Center. This is where we use computer simulations to recreate various different driving scenarios in order to continually develop automotive technology. In the field of air management, our worldwide network works to develop, apply, and produce a system of components with design and functions that are perfectly adapted to the needs of the vehicles of our international clients. Our products manage the following factors: amount of air take, air movement, the mixture of air and fuel in the intake manifold, and the correct composition of the air. Our experience as a system supplier plays a major role in the development of our intake modules. We have the necessary know-how to develop and produce top-quality intake modules in line with the wishes of our customers, with functions that work in perfect harmony with the other vehicle systems. The result is a high level of integration, which in turn makes both the engine assembly and the logistics for our clients easier, resulting in cost reduction. Let's take a look at the individual components. Here, the plastic or metal intake manifold. With its special geometry, it influences the engine cylinder charge cycle processes, which give the engine its respective performance characteristics. The design and optimization of the intake manifolds is done jointly with our customers. For every model, we apply all our experience and product knowledge regarding the relationship between intake air adjustment and combustion in the engine in order to optimize performance and emission values. This is where the charge motion valves are needed. They influence the air path to the combustion chamber and ensure targeted turbulence in the combustion chamber in order to achieve optimal combustion. Of course, there is no manual operation, which would never fulfill the high demand for control accuracy and diagnostic capability. The task is carried out by an actuator with an electrical motor, which is individually adapted to the needs of the engine, the General Purpose Actuator, GPA. Our throttle device, DVE, is attached directly to the intake manifold. In order to reduce the smallest adjustable airflow settings still further, we've optimized the geometry of the throttle. At the same time, we've also been able to fulfill the wish of our customers for as much freedom as possible in the engine construction and applications. And most importantly, compared with conventional models, we were able to reduce the weight of the DVE by 25% through the use of composite materials. The Canister Valve TEV is designed by the integration of client-specific connectors and the configuration of intake and outlet in individual model types. As with all the components, the TEV impresses with its lightweight, compact design and, of course, the high level of vibration strength. Whoa, steady now. With the exhaust gas circulation outlet, air management offers the right solution for the exhaust gases created during the combustion process. It mixes the exhaust gases with the fresh air intake, enabling a recirculation rate of up to 60%. And another important product for exhaust gas treatment, the secondary air pump. It ensures that the catalytic converter is able to reach its operating temperature quicker, thereby ensuring compliance with the future exhaust gas limit regulations. The driving pleasure begins when the foot hits the pedal, and our long-life accelerator pedal modules increase this pleasure tenfold. They can be adapted easily to the vehicle type of our customers and are designed according to ergonomic principles in accordance with the wishes of drivers, both men and women. And now on to the road test. Air management from Bosch. One-stop shop for all components, adapted to the individual needs of our clients. For sporty performance and driving pleasure with minimal consumption and low emissions.
Bosch, invented for life.
Let's take a closer look at a situation with a mild and a strong hybrid. For starting off, the electric motor is the ideal source of drive power, as it develops its maximum torque from a standstill. When accelerating from a standstill, the internal combustion engine is disconnected. The electric motor alone, fed by a high-performance battery, is the sole source of propulsion. When the accelerator is depressed more firmly, the internal combustion engine starts up. Both drive sources then simultaneously provide maximum torque to accelerate the vehicle. While traveling at a constant speed, the internal combustion engine provides the drive energy. The electric motor now generates current, charging both the high-performance battery and the normal battery. Should the driver wish to accelerate very quickly, the direction of the electrical current is switched in a flash. The electric engine now delivers maximum performance. Combustion engine and electric engine work together to accelerate the vehicle, enhancing the pleasure of driving. When the driver releases the accelerator, the internal combustion engine switches off and disconnects from the electric motor. The energy provided by the vehicle's motion now drives the electric motor, which charges both batteries more strongly. When the driver brakes, the electric motor provides deceleration with its maximum drag torque. The energy generated by the vehicle's motion is converted into electrical energy. If the required braking torque exceeds the maximum drag torque of the electric motor, the conventional wheel brakes are triggered. As soon as the vehicle comes to a halt, the electric motor stops. Unlike mild hybrids, the strong hybrid can drive short distances using the electric motor alone. This helps reduce emissions, particularly in urban areas where traffic can be very heavy. Hybrid technology makes driving more environmentally friendly and sometimes even emission-free. Significant fuel savings and a reduction of CO2 emissions have already been proven. At the same time, driving characteristics are improved because the two drive sources work together perfectly as a team. Hybrid technology from Bosch for enhanced driving dynamics with lower fuel consumption and reduced emissions.
Bosch, invented for life.
Welcome to the Bosch Virtual Driving Center. Here we use computers to simulate a variety of driving situations to constantly further develop automotive technology. So let's just take a look at the world of transmission control. Over the years, vehicle electronics have become ever more complex. In the 90s, luxury class cars were fitted with almost 2,000 cables, representing a total length of approximately 3 kilometers. The percentage of electronics used in vehicles has continued to rise in recent years, but bus systems and the direct integration of components have made it possible to reduce cables and interfaces to a minimum. One example of this is the control unit for the electro-hydraulic module in modern automatic transmissions. The control unit is located directly in the transmission and not outside it, as used to be the case. In the past, 88 leads were required for connection. Now only 16 leads are necessary. That means enhanced reliability thanks to fewer interfaces. The control unit is now smaller and can be built in directly, reducing the weight of the vehicle and creating more space. This means easier assembly and logistics for the manufacturer. But direct installation means that the control unit must be quite resilient, as the installation environment is anything but comfortable. Here in the thick of things, temperatures between minus 40 degrees Celsius up to plus 140 degrees Celsius and vibrations of up to 30 G mustn't keep the control unit from doing a perfect job. The electro-hydraulic module from Bosch, in addition to the control unit, also includes pressure regulators, solenoid valves, connections, temperature sensors, and pressure switches, all in a single unit. The benefits are numerous. Enhanced reliability, greater precision, a significant 30% weight reduction, lower production and logistical outlay for the transmission manufacturer. Just like our credo, safe, clean, economical.
Bosch, invented for life.
Welcome to the Bosch Virtual Driving Center. Here we simulate different driving situations on the computer in order to ensure the continual further development of technology for the automobile. And we do this very successfully in the field of gasoline systems. The goals for engine management systems are clear: dynamic acceleration, lower fuel consumption, and the lowest possible emissions. We achieve this by constantly improving the performance of our products. The example of gasoline direct injection with Di-Motronic shows you how. 4 functional modules are the focal point. First, cylinder charge control. This ensures that the correct amount of air is supplied. Second, precise injection directly into the combustion chamber. Here, the injected fuel, together with the air that's been sucked in, form a combustible mixture. Third, the ignition. For high efficiency, the right timing is crucial. And fourth, the exhaust treatment system. The Lambda closed-loop control ensures maximum effectiveness of the catalyzer. Nothing earth-shattering, you might think, but bursting with innovations just the same. Creating a perfectly functioning system from many components, a system that reacts ideally to any situation, is an art, because each situation demands an ingenious strategy from the engine management. Let's take the example of starting a cold engine in low outside temperatures. Here especially, the air mass has to be controlled with the utmost precision. This is why Bosch has developed the first plastic throttle device. This saves a great deal of weight and improves function, as the valve can be adjusted with superb precision. But that's just one example among many. Now we'll take a ride on a country road, completely relaxed in the lower speed range. Maximum precision is also required in everyday situations such as this. The high-pressure fuel pump delivers the fuel and brings it to an injection pressure of up to 200 bar. The special thing about this pump is, it doesn't matter whereabouts in the world you are, it's suitable for all qualities of gasoline all over the world and lasts the entire life of the automobile. But sometimes you need more than low torques. At high speeds, function has to be exact. For example, when overtaking on the freeway. With its homogeneous mixture, the Di-Motronic provides the driver with the correct torque. Now it's a question of the right timing. The higher the engine speed, the faster all the injection processes have to be measured, calculated, triggered, and executed. Evaluating sensor data on the required torque, air mass, temperatures, and pressures. Controlling the air charge by means of the throttle device. Calculating the fuel mass and timing for injection. Actuating the injector. Calculating the moment of ignition, producing ignition sparks. Measuring the exhaust gas composition and regulating the mixture formation via the Lambda closed-loop control. And all this for every single injection, always adapted precisely to the momentary operating conditions. These days, the engine management system must provide not only reliability and dynamics, but also exhaust gas treatment for the benefit of our environment. In stop-and-go urban traffic, the operating conditions are constantly changing. The required torque changes in fractions of a second. In order to keep harmful emissions to a minimum at the same time, the Lambda sensor must precisely analyze the flow of exhaust gas. Oops, sorry. We continue to further develop the Lambda sensor to make it ever smaller and lighter, so that it can be installed closer to the engine. The sensor will thus be ready for operation more rapidly when the engine is started. The Di-Motronic receives information from the Lambda sensor about the concentration of oxygen in the exhaust gas, and this in millisecond intervals. This enables the Lambda control of the Di-Motronic to react immediately, keeping well within even the most stringent emissions limits.